Here we're going to look at vector addition and scalar multiplication, and we're going to start out with looking at the scalar multiplication, and that means we're going to take just a scalar, which is a number, multiplied by a vector. And to look at that, we're going to start out by looking at this in kind of a graphical representation first, then we'll look at it more of a algebraic way. So here, if I'm just drawing in 4 vertical lines here, to be a reference. If we have, let's say, our vector v, and that is represented here, and I want to look at what would happen if we were to take that vector and simply multiply v by 2. Well, notice the direction is not going to change. The only thing that's going to change is the vector will be twice as long, so the magnitude will be doubled. And if we were to take 1/2 of the vector, then once again we're going to cut the magnitude in half. Now what happens if we put a negative in front of our vector? Well, that's going to cause the vector to point in the opposite direction, so it would, in this case, would go kind of down to the left. And of course, if we were to take a -3 times our vector, that's going to have the vector go in the opposite direction, but it's going to have a increase the magnitude by 3 times, so it's going to be 3 times as long. So that's kind of a representation of what happens when we take just a scalar and multiply that by our vector. And that's really easy if we look at it kind of from an algebraic standpoint. If we had our scalar 4, and here's the component form, 3, -8, whoops, we'd have a bracket here. So 4 times 3 comma -8, so 3, -8 is our vector, 4 is the scalar, and we're basically just going to distribute the 4 to each component here, and we would end up with 4 times 3, which is 12, and 4 times -8, which would be a -32. So this here would be 4 times the vector 3, -8. So you're simply going to multiply each part of the vector by the scalar. Okay, next we want to look at vector addition. And if we're going to add 2 vectors together, we're going to start out once again looking at this from kind of a visual standpoint. If we are given, let's say, 2 vectors, u and v, and let's say vector u is pointing this direction, and we'll have v going this direction. And we want to actually look at what is u plus v. So if we take u plus v, what is going to be the result? Well, when we add vectors, we think of adding, what we would say is, we think of this as the terminal point, the head, and the initial point here is referred to as the tail. So again, this would be the tail. We could think of the terminal point here as the head. We're going to actually add our vectors head to tail, which means if this is our vector u, then we would take v, okay, and we would move it and add it head to tail. So we're going to take v, we're not going to change the direction, we're not going to change the magnitude, but I'm going to move this initial point up here to the terminal point of u, and we'll keep the same magnitude and direction. So there's v. So if we're going to add u plus v, then that would be starting from the initial point of u and going to the terminal point of v. So this would give us u plus v. So that is simply how we add 2 vectors together. Again, we refer to this as adding them head to tail. Now you can also look at this as u and v as representing the sides of a parallelogram, and sometimes you'll see people define it that way. So this here would be v, and then if this here is u, then you can see that u and v, if we complete this, you end up with a parallelogram, and the diagonal would be u plus v. But I think it's just as easy to think of this as adding u and v head to tail, and simply going from the tail of u and connecting that to the head of v. And if you had multiple vectors, for example, if we had a vector that went this way, and then we had another vector that went down, one that went up, over, and back down, if you were to add all of these vectors together, you would simply start here at the initial and go to the terminal point of your final vector, and that would be the sum of all of the vectors. All right, so now let's look at this with some actual, well, before we look at that, let's see what happens if we were to subtract vectors. So we'll start again with, here is u, and here is our vector v, and we want to look at what happens if we were to take u minus v. And really the easy way to think of this is, what if we just simply took u plus negative v, right? If we're subtracting, that would be the same thing as adding a negative. So I want to kind of look at this again, and we're going to use the same idea that we used up here with the vector addition, because now we're adding, but we're adding the opposite of v, so therefore we still are thinking of using subtraction. So once again here, we're going to start out with, if we have our vector u, and I'll try to keep this the same direction. So here's u. And now we want to add negative v. Well, v is pointing to the right, so if we want a negative v, then that means v then would point to the left. So if this here is negative v, so if we want to look at u minus v, or in this case u plus a negative v, then the resultant would be from here to here, which this would represent u plus negative v. In other words, that would be u minus v. Okay, another way to think of this as far as subtraction. Now, for me personally, I kind of like thinking of it this way with adding the negative. I think that makes really good sense. And sometimes you'll hear when you're subtracting vectors, when we were adding, we said we add head to tail. But here, when we're subtracting, if this is u, we actually say when you're subtracting vectors, we're going to subtract tail to tail. So that means if that is u, then we would connect the tail of u with the tail of v. So here is v. So the subtracting part then we would take and connect the head of v, which is the terminal point, and connect that with the terminal point of u, and this will give us u minus v. And if you look closely, u minus v here, isn't that vector pointing basically in the same direction, in the same magnitude as the vector we had over here? So we can notice that either way, we're subtracting u minus v. Okay, so now let's look at this more from an algebraic standpoint when we actually have some numbers. If we have our vector u is equal to 2, 3, and then if v is equal to 4, 0. So for part A, we want to look at how do we add u plus v. Well, I'm going to go ahead and do this from an algebra standpoint. We're just simply going to take and simply add the two vectors together, and we're going to add the corresponding components. We're going to take the x-coordinate, which is 2, and the x-coordinate over here with v, which is 4. So we would simply take 2 plus 4, and then 3 plus 0. So we would therefore end up with 6, 3. Now, let me look at this from a graphical standpoint. So if we look at this, we'll hopefully confirm our results that we came up with. So if we start with u, which is 2, 3, So here we have, if we go, so now remember this is the component form, so 2, 3 says we're going over 2 and then up 3. So there's that point, which means this would be our vector u. And now v says that we're 4, 0. So that means we would go over 1, 2, 3, 4, and we would actually have this here as our vector. But remember, we want to add that head to tail, so we're going to move v up here, and then we need to go over 2, so that means we're going to go over to here if we add those together. And then the resultant would be from here to here. Okay, again, we're adding head to tail, so we go from the tail of the first vector to the head of the second one, and we get u plus v. And where's this point right here? Well, it's located at 6, 3 is what we found down here for the vector. So that says we're going to go to the point 6, 3, and there we've added u and v together. So here from an algebra standpoint, you're simply adding your corresponding parts. So in other words, if we had the following, simply u minus v, then we would simply subtract. We would take 2 minus 4, and then 3 minus 0, and we would end up with negative 2 and a positive 3. And what if we look at a combination here? What if we take 2 times u, so there's our scalar multiple, minus 3 times v? Well, that means we're going to have to take 2 and multiply that by u, which is 2, 3, minus 3 multiplied by 4, 0. So now our first step is we need to distribute the 2. So we're going to multiply the scalar by each part, and we're going to end with 2 times 2 is 4, 2 times 3 is 6. And now here we need to be careful. There's 2 ways we can handle this, and the way I prefer to do this is we have to multiply the 3 here by the 4 and the 0, but I'm actually going to include the negative sign. So if I include the negative sign and distribute that with the 3, then I can change the negative sign here to a positive, because I'm going to take negative 3 times 4, which is going to make it a negative 12, and a negative 3 multiplied by 0 is going to remain 0. Now, if you didn't distribute the negative, then you could distribute the 3, and you would have gotten 12, 0, but the negative sign would have stayed out front. So to make it a little bit easier, I prefer to make it addition, so I'm going to distribute the negative sign. So now we simply have our 2 vectors, and we're simply going to add those together. So 4 and negative 12 is negative 8, 6 and 0 is 6. So this would be the resultant, or the vector that we have from taking 2 times u minus 3 times v. And keep in mind, negative 8, 6, that is our x-coordinate and y-coordinate for the terminal point of our vector. So what that would mean, from a graphic standpoint, if we were to add these 2 vectors together, we would then go 6 units, draw this a little bit different here. That means we would go 6 units to the, whoops, wrong direction. Our x is negative 8, so that means we would go negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And then we would go up 6, 1, 2, 3, 4, 5, 6. So our point, ran out of room here. We would go negative 8 and then up 6. So this here would be our vector. Again, the negative 8, 6, that's the terminal point, because we know the initial point is starting at the origin. Okay, 2 more properties I want to look at here with our vectors, and that'll finish up this video. And that is, if we were to take u, and if we add that to the negative of u, So u plus a negative u. Now this you want to be careful. This is going to be equal to what we call the zero vector. Now, if we don't have the line up here, if it's not bold, or if I put a line, the zero like this is just a zero scalar. Okay, there's only magnitude, there's no direction. But when we add two vectors together, we're actually going to get what's called the zero vector, which means this is representing the vector 0, 0. Okay, and what that really means is if you take a vector here, if this is u, and then if we were to add a negative u, then that means we would go from here to here. That would be our negative u, and realize we're back where we started from, so therefore we end up with the zero vector. And then of course if we take a scalar, now 0 here, this is a scalar, being multiplied by a vector u, and 0 could be multiplied by any vector u, and what that means is we're going to end up with, once again, the 0 vector, where this is representing 0, 0. So keep in mind here, the 0 at this point is a scalar. Okay, 0 is just representing a number, whereas u is representing any vector. Okay, so of course if you take a vector and add the opposite, you're going to get the 0 vector, and if you take a scalar 0 and multiply that by any vector, you will also get a 0 vector. So to go back here and review, if we're looking at scalar multiplication, you're just taking that number and multiplying that to your vector, so you're going to distribute to the x and the y, and really the only thing we're changing there is the magnitude or the length of the vector. And if you were to multiply by negative out front, that's going to change the direction of the vector to going in the opposite direction. And vector addition, you're simply adding your vectors graphically head to tail. Or if you're looking at subtracting, we can think of that as adding the opposite of the vector, or we can think of adding the two vectors tail to tail. And algebraically, you're just simply adding or subtracting your x coordinates if you're adding your vectors or subtracting.